Okay, hi and assalamualaikum. Okay, so in this video, I'm going to explain about coefficient of determination. Okay, so this one is related to your regression, but it's a new constant that you need to find out, okay, to verify either your regression line is fit or is it valid to be used for your correlation question. Okay, so there are two different formulas that you can use to find out your coefficient of determination, okay, which we use r square as the symbol for coefficient of determination. Okay, so the first one is just simply, okay, s prime xy square over s prime xx multiplied with s prime yy, or there is another one formula which is, okay, 1 minus sum of y minus y square over sum of y minus y mean square. Okay, so it depends on the questions, okay, which formula that you're going to be used. Okay, so both formulas can be used if you are given x and y data, but only equation 1 can be used if you already if the question give you the summarized data, which is they simply give you what is sum of x, sum of y, sum of x square, sum of y square, and sum of xy. So that therefore for that one you can only use first equation, first formula. Okay, but if they give you x and y data, so you have the pleasure to choose either to use equation first or equation 2. They both will give you the same answer. Okay, so r square will always be a positive value, so please take note. Okay, and why do we calculate r square? So we're going to find from the r square, we're going to find out the percentage. Okay, so the percentage of variation of y that is accounted or explained due to the variation of s. If it's high percentage, that means your regression line is the regression line that you determine can be said is valid. Okay, but if the percentage from your r square values is very little, that means our regression line is not that reliable, okay, to determine your unknown variables, okay, or for prediction or estimation of others unknown variables. Okay, so let's look at question exercise 4 here. Okay, okay, so you were given x and y values. Okay, so I'm going to show you how I'm going to use second equation first. Okay, so for this one, okay, because there is a special character here, y with a triangle and then y bar. So this y bar is actually a mean. Okay, and this y with triangle here, it comes from the y of our regression line. Okay, so that means in order to find out what is y here, you need to find out your regression line first. Okay, so from these tables of x and y, first we need to calculate x square, y square, and xy. Okay, so I already calculate my x square, y square, xy, and from there I already calculate the sum of my x, xy, okay, and all the variables. Okay, so now, okay, so we have to determine the least square regression line of y on x. Okay, so y equals to a plus bx. So find out what is b first. So s prime xy is simply and sum of xy minus sum of x multiplied with sum of y. Okay, so there is 1, 2, 3, 4, 5, 6, 7, 8. 8 samples, so n is 8. And then sum of xy, okay, we already calculated it before, minus 61 multiplied with 61.1. Okay, so this one equals to 814.5. Okay, so next, s prime xx, okay, because it's line y on x. Okay, sum of x square minus sum of x square. So your n is 8, your x square, okay, the sum of x square is 623 minus 61 square. Okay, so this one, it becomes 1263. Okay, then I'm going to substitute into my B formula. Okay, so B is equals to S prime xy divided by S prime xx, okay, which is 814.5 divided by 1263, okay, which equals to a positive number 0.645. Okay, next I'm going to find out my A. So A is simply Y mean minus B x mean. Okay, so which is my Y mean is sum of Y. Okay, my sum of Y is 61.1 divided by the number of sample, which is 8. Okay, minus 0.645 my B, and mean of my X is 61 divided by number of sample, which is 8. Okay, so find out what is your A. Okay, so it's equivalent to 2.72. Okay, so let's write it as an equation. Okay, Y equals to A plus BX. So I'm going to substitute my A, which is, we got it as 2.72, plus my B is 0.645, and this is X. So that is your answers for question E. Okay, so from here, okay, they ask you to calculate the coefficient of determination between X and Y. Okay, so as I told you, for this question, I'm going to use this new formula. Okay, so R square equals to, okay, 1 minus R square equals to okay, so in this equation, I'm going to use this formula. I'm going to show you how to determine the coefficient of determination, okay, using this formula. As you know, there are two formulas, but I'm going to use this formula for this one. Okay, so that means you need to find out what is your Y this. Okay, so this Y comes for your regression line, okay, and then your Y bar. So Y bar is your mean. Okay, so your mean, okay, for question B, mean is simply sum of Y divided by your N. So sum of Y is sum of our Y, which is equivalent to 61.1 divided by 8. Okay, equals to 7.6375. Okay, so how are we going to find out what is this Y values? Okay, so first, let's write down again what is our Y values from the given data. Okay, so this is the Y values from the data given. Okay, so you can scroll up to the given data. Okay, so Y, so I've just substitute into the new table. Okay, so from here, I'm going to find out what is my special Y here, Y with apostrophe. Okay, so this Y is actually the Y values of the regression line. Okay, so Y values using the regression line. That means we're going to find out this Y by substituting all the X values from the data given. Okay, so at Y equals to 2.5, okay, so your X equals to 1. Okay, so let me show you an example. Okay, at Y equals to 2.5, okay, so your X equals to 1. Okay, so your Y here will be 2.72 plus 0.6451. So that equivalent to 3.365. Okay, so this is the first value. Okay, so next, when your Y equals to 3.6, okay, so your X equals to 3. Okay, at Y equals to 3.6, your X equals to 3. So this Y special regression, well, your Y regression is 2.72 plus 0.645. Now the X value we're going to substitute with number 3. Okay, then find out what is your new Y of regression, which is 4.655. Okay, so this is 4.655. Okay, so please continue to fill up the data until the values of Y for your Y equals to 10.5. Okay, so I already calculated all the regression y values. Okay, so next we're going to find out y minus y regression and square of it. Okay, so that means, okay, so for the first one it's 2.5. Okay, 2.5 minus, okay, 3.365 and square. So I got it as 0.748. Okay, so next, okay, so it's 3.6. Okay, 3.6 minus 4.655 and square of it. Okay, so it's 1.113. Okay, so please continue until you fill up all until 10.5 for your y. Okay. Okay, so next we're going to find out y minus mean y and then square. So mean y is simply, okay, your y bar equals to sum of y divided by n. So your sum of y is 61.1, okay, divided by n, which is 8. Okay, so equals to 7.638. Okay, so this y, okay, the first one at y equals to 2.5. Okay, so 2.5 minus the mean 7.638 and then square. So you get here to be 26.399. Okay, so when y is 3.6, okay, so then values of y bar remains unchanged. You just simply change the y values. Okay, and then at 4.8 is again 4.8 minus your mean y, which is 7.638, and you square it, you get 8.054. Okay, when it's 5.9, okay, so it becomes 3.021. Okay, then 12.2. Okay, so 20.812. Okay, so please continue to do until the last y value. Okay, so after fill up the tables, okay, completely with y and then y regression, okay, y minus y regression square and y minus mean y square. So next, find out what is the sum of your y minus y regression square. Okay, so it's 38.739. Okay, I already calculate this one. Okay, then y minus y bar square. Okay, so your mean, and then find out what is the sum of the values, which is 104.399. Okay, so next we can find out our r square using this formula. Okay, so r square equals to 1 minus sum of y minus y regression square over, okay, sum of y minus y mean square. Okay, so 1 minus, okay, sum of your y minus regression y square is 38.739, okay, divided by 104.399. Okay, so 38. So you get a positive numbers 0.629. Okay, so r square will always be a positive number. Okay, so this is your coefficient of determination. Okay, coefficient of determination. Okay, so I'm going to show you how we use the second formulas of coefficient of determination, which is r square equals to s prime xy square over s prime xx times with s prime yy. Okay, actually in the previous exercise you can still use this formula, but I just simply want to show you how we use another formula. Okay, because sometimes the question might ask you to calculate, use this formula to determine your coefficient of determination, or use this formula to calculate coefficient of determination. Okay, so for this kind of questions in exercise 5, okay, so you have a summarized data instead of every recorded data x and y. Okay, so they already give you the summarized data, so therefore you cannot use the another one equation, which is equals to 1 minus, okay, sum of y minus y regression square over sum of y minus y mean square. So this one you cannot use because you don't know what is the values of y. Okay, because to find out this y minus y regression square, you need to know what is your y values. Okay, and you need to calculate for every y regression values. Okay, but in this example, you can't use this equation. So therefore, it leaves out you with one simple equation, which is s prime xy square over s prime xx multiplied with s prime yy. Therefore, you have to find out what is your s prime xy, which is n sum of xy minus sum of x multiplied with sum of y. Okay, so a sample of 15 pairs. So this is your n. Okay, and x equals sum of x square, sum of y square, and sum of xy is already given. So we can just simply substitute, okay, into the equation. Okay, then calculate it. Okay, so okay, next find out what is your s prime xx. Okay, so n sum of x square minus sum of x square. So 15 1240 minus 120 square. Okay, it's 4200. And then s prime yy, so n sum of y square minus sum of y, and then we square it. So 15 multiplied with 3695, okay, minus 235 square. Okay, which is equals to 200. Okay, so next we substitute all the values to the equation. S prime xy square, s prime xx multiplied with s prime yy. So s prime xy is 720 square, okay, over 4200 multiplied with 200. So equals to 0.617. So this is the coefficient of determination for your exercise 5. Okay, so this is actually your question B. Okay, so determine the regression line of y on x. Okay, I forgot to discuss on question A. Okay, so regression line of y on x, so that means it's y equals to a plus bx. Okay, okay, so your B, if you still remember, B equals to s prime xy over s prime xx. Okay, so we already calculate s prime xy, which is 720, okay, over your xx, which is 4200. Okay, it will be a positive value, which is 0.171. Okay, next we're going to find out our A. So A is y mean minus b x mean. Okay, so your y mean, okay, sum of y is given as 235 divided by 15, okay, minus your b 0.171, and the mean of x, sum of your x is 120 divided by 15. Okay, so I got my A to be 14.30. Okay, then we can rewrite the equation. Y equals to a plus bx. Okay, substitute your a 14.30 plus your b, okay, 0.171 and x. So that is the least square regression of line y on x for this equation, this question. Okay, so thank you for watching. Bye bye.